Hey everybody, this is Mr. Bells coming to you, Precalc A. This is section P-2. Remember, all these things are prerequisites, and I'm just going to try and give you a few different topics, problems as we go through here and kind of talk about them and see how we do with them. Okay. So first thing, if I have, and again, I don't want these to be too obvious, but I know that quadrants here are 1, 2, 3, and 4. And if I said, hey, what's that location? We've got to make sure that we're right. So locations on a coordinate axis system are always x comma y. And if these intervals are 1s, 1, 2, 3, 1, 2, this location would be 3 comma negative 2. However, there's going to be lots of times where the intervals that we use aren't exactly the same. That this might be a 2, 4, and 6, and this might be a 5, negative 5, and a negative 10. So we have to be very careful about how we scale these things and how the book scales them. So make sure that you are paying attention to what those are, because those can definitely affect, especially like slopes of lines and stuff. Something that you might think is one slope is actually something completely different based on the coordinates. So if this was a gap by 2 on the x-axis and gaps by 5 on the y-axis, then this point would have been 6 comma negative 10. And you can see those are obviously two different locations with two different ratios between the two. Okay, there's another section. How do we take these like an absolute value expression like this, and can I write it without absolute value symbols? And the answer is yes. Well, pi minus 4 is going to be a little bit less than or around negative 1, right? Because pi is about 3. But if I was to rewrite this as 4 minus pi, bigger number minus littler number, then I don't have to use the absolute value symbols anymore. I can just do it like that. Okay? So we have another type of problem. Find the perimeter. So I've got a triangle of 2, 6, negative 7, 1, and 8, negative 3. And anybody who had me for geometry before or data probably knows how much I use the terms DIMS. Stands for doesn't make sense. Well, I want you to be able to sketch this picture over here first and get a decent idea of what the answer might be before we even start. So 2, 6, 1, 2, 3, 4, 5, 6. And if you have graph paper, that's awesome. You can go ahead and use that. Negative 7, 1, so negative 7, and then a 1, so I got something over here. And then 8, negative 3, so 8 right over here, and negative 3, something about like that. So this is what my triangle looks like. It almost looks like it could be an isosceles. I guess I'll find out after I figure out what all of these distances are. But I want to have a decent idea of it. So if this length right here is 7 going up that much, then that length's longer than 7, and that length's longer than 7, and that length's longer than 7. So my guess is this total length of these three things could potentially be somewhere in the 30 to 40 range. Now again, this is just quick off my head. I didn't sketch anything. But my point is, if I do the math and I get a perimeter of 56, I'd be like, whoa, that's way too big. Or if I get a perimeter of like 13, ooh, that's way too small. That means I've probably messed up my positives and negatives. Okay? So again, finding the perimeter means to find all of those lengths. So let's go ahead and put these dots in here too. So here's A, and here's B, and here's C. So I'm going to go ahead and find AB first, this length right here, and then I'm going to kind of look at it and go, hey, does it make sense? So the distance from 2 to negative 7 is 9. So I have 9 squared. And the distance from 6 to 1 is 5. And I have 5 squared. And that's 81 and 25. So that total is the square root of 106. So that gives me a little bit more than 10. I can buy that, a little bit more than 10, right? Okay, that's AB. And then I'm going to do BC. And hopefully you start to get to be able to do the distance formula like the same way that I'm doing it. And I don't know if you can do it in your head as quickly as I can, but I'm hoping that you get better at it as we go. So how far is it from negative 7 to 8? Well, that's 15. 15 squared is 225, but I'm going to leave it as 15 squared right now. And then from 1 to negative 3, that's 4. So 225 and 16, that's 241. So the square root of 241, which I know that that's a little bit bigger than 15, because that's really not much at all, right? And then I got to do AC. So AC is my last one. So I've got, again, about 10 and about 15. That gives me 25. So I feel like I'm in the good range right there. And BC definitely was the longest one that could be 15. So I got to do AC. So 2 to 8 is 6 squared. And now the differences between the y. 6 to negative 3 is 9 plus 9 squared. So that's, I'll write them down this time, 36 plus 81. So I got 36 plus 81, and I could take all of these ones if I wanted to and leave them in radical form, or I could put them together. So as a whole, without losing anything, I would do square root of 106 plus square root of 241 plus square root of 117, and that would be complete as it was. If I could, you guys know that in data we did simplifying radicals, and I might be able to break some of these down, but I really don't think I can. I don't think any of them work out for me very well. Nope, doesn't look like it. Like this can go 2 and 53, but 53 is not going to break down any further, and 241, I don't think that's got anything nice. So I'm going to say that those are there, but let's go ahead and get an approximation on this. So take your handy dandy calculator, if you can right now, and I'm going to go ahead and, there, does that show up a little bit better for you guys? Maybe go ahead and put those in here. So I got 106 raised to the 0.5 power. That's the same as a square root, right? Plus, plus 241 raised, I forgot my plus sign, plus 241 raised to the 0.5 power, plus 117 raised to the 0.5 power, enter. And you can see I get 36.63, 36.63, and I'm feeling pretty good about that. And then I asked you before, I'm like, is this thing scalene or isosceles or equilateral, whichever it is? Well, scalene means that all three sides are different lengths, and you can see all three sides here are definitely different lengths. So there's my perimeter. I do know that it's a scalene triangle. I'm not positive on it's acute, obtuse, or that this angle right here looks like it could be obtuse, and I know that you guys could use some trigonometry right now, right? You could use law of cosines to be able to figure out what that angle is given the three sides, but that's not for this unit. So, but if you want to give it a try, give it a shot, see how we do. Okay. So here we go. How do I prove a triangle is a right triangle? Well, there are two different ways to prove triangles are right triangles. One is the slopes. So if you have any two sides of a triangle, let's say segment DF and segment EF out of triangle EDF, if these two segment slopes are opposite reciprocals, then you know that that forms a right angle. And again, you guys know slopes are y2 minus y1 over x2 minus x1, or the change in the y values over the change in the x values, right? That's a pretty basic way to be able to find a slope if you got coordinates on the coordinate plane like these ones were up here. Okay, and then the other way is Pythagorean theorem. So if the two shorter sides equal the longer side when they're all squared, then we know that that works. So if we look really close on this one, you can see that this is 106 and 117. So if I square the square root of 106, that's 106. And on my handy dandy calculator here, I can do 106 plus 117, and I get 223. And you can see that that's really close to 241, but it's not 241. So that means that this triangle, this angle right up here, is not a right angle. You'd also know that the slopes right here, if we check the slopes for them, let's go ahead and do that. Slope of AB. So the slope of AB, 6 minus 1 is 5. Slope of AB, 5. And then 2 minus negative 7 is 9. So that slope is 5/9. So that's AB's one. Now we want to do AC's. And they should be close to being opposite reciprocals, but they're not. So AC, we'll do that one next. The slope of AC means I'm doing these points. So 6 to negative 3, right? 6 minus negative 3, that's positive 9. And then 2 minus 8, that's negative 6. And you're like, whoa, those are really close. This is positive, this is negative, so it works for that part. 5/9 becomes 9/6. They are really close, but this is still a no. Okay, so again, proving a triangle is a right triangle. You can prove it by showing the slopes are opposite reciprocals of each other, or you can show it the Pythagorean theorem works out for them. This one, really close, but neither one of those things work. Okay, so we're going to go right down here now. We're going to go to this thing. You're like, what's this thing? Oh, that's data analysis all over again. So this is a circle, and I want to know where the center is and where the radius is. And you guys know, right? You guys know that we could use Desmos. Desmos is an awesome tool. The center of this circle is at negative 6, 4, and the radius equals 6. Radius is 6. Because we know that this is the shift on the x, this is the shift on the y, and this is the radius squared. So whatever this number is over here, I just simply square root it to get the radius. Whatever is moving the y here, I use the opposite of that. So if that's minus 4, that's going to be a center of positive 4 for the y value. And whatever's here, if this is positive 6, we use the opposite of that, so negative 6. So 6 to the left, 4 up, and then a radius of 6. And I know with this circle, if I need to go back to conic sections times, both variables are squared. They are added together. You can see that the y is a positive and the x is a positive, and they both have the exact same number in front of them, which is a 1. And when those are both 1s, then we can easily just take over here and see that as the radius squared. Okay, so the last thing we're going to try and do in this unit, this section right now, is a perpendicular bisector of segment AB. So how do I find that? And I'm going to use my graphing calculator a little bit in this, so hopefully you guys can plot some of this stuff off. So I'm going to teach you a few different things. First, I'm going to do it by hand. So I'm going to have to go here, and I want you guys to do this by hand too. So I got 4, 6, and negative 7, 3. And let's go and draw this in. So 4, 6, 2, 3, 4, 1, 2, 3, 4, 5, 6. And negative 7, 1, 2, 3, 4, 5, 6, 7, and 3. And so this is what I got. So there's the segment itself. So a perpendicular bisector of that segment is has to go through the midpoint and has to be perpendicular to that. So what I'm looking for is I'm looking for this line right here. Okay, which means when I'm done, my slope better be negative, and my y-intercept better be positive. If this, my sketch is pretty good. Positive and kind of low. I'd say probably less than 3. Okay, so that's what should happen when I'm done. So the first thing I got to do is I got to find out the slope of this line, because I know if it's a perpendicular bisector, the slopes have to be opposite reciprocals. So let's go ahead and find out the slope of AB. So y to y, so 6 minus 3 is 3. 4 minus negative 7 is 11. So the slope of this line is 3/11, and that looks about right, okay? Which means my new slope has to be negative 11/3. Okay, opposite, positive to negative, reciprocal 3/11s to 11/3. Okay, so now it also has to go through this point. Well, that point's the midpoint. So if this is the slope of AB, now I need the midpoint of AB. Well, that's add the x's together, right? 4 and negative 7 is negative 3. Half of that is negative 1.5. And 6 and 3 is 9. Half of that is 4.5. And before I move on, I look at this and go, hey, is that about right? Negative 1.5, 4.5. Yay, it looks about right. So everything that I've seen makes sense so far, okay? So I know I'm trying to find the equation of this line right here. Find the equation of the perpendicular bisector. I know that all lines need to have a slope and a y-intercept like this. Y equals mx plus b. Are you good? So I know my slope. Y equals negative 11/3 x plus b. I just don't know my y-intercept. I need to find out where that point is right there, because then I can have a line. So I have 1, 2, 3 variables. So that means I have to know an x and a y in order to find out the b. Well, I know only one point on this line, and that's that midpoint right there. Well, that's that one. So let's plug them in. So 4.5 goes in for the y. Negative 11/3 goes in for the slope. The x is negative 1.5. And then this is the b. Okay, so here we go. So I have to do this times this, and then move that answer to the other side. So let's go ahead and pull out my handy dandy calculator here again. And I got negative 11/3 times negative 1.5, enter, and I get 5.5. Awesome. So that equals 5.5 plus b, 4.5. Okay, so I subtract 5.5, subtract 5.5, and it's at this point right now where I have just a tinge of, oh, that kind of sucks for me. It says my y-intercept's negative 1. My y-intercept's negative 1. Which means if I go up to my picture's maybe not as good as I was hoping, but my equation should now be y equals negative 11/3 x minus 1. That's the equation of my perpendicular bisector. And now you can kind of see, if I look at it, this is maybe obtuse, and maybe my line should have been a little bit more like this. And if it's a little bit more like that, then we're really close to negative 1 if I make it a little bit more perpendicular. Okay? But everything I'm going to do now is going to be on the graphing calculator, so buckle up, kiddos. Doesn't that look good? Okay, so here we go. First thing I'm going to do is I'm going to make sure that I turn my plots off. So hit second y equals, and we're going to hit number 4, plots off. Hit enter. Good deal. And then I'm going to hit second and the plus sign, and then I'm going to hit number 4, clear all lists. And so help me, I'm telling you, you've got to practice this stuff. Here, so it says done. Again, second plus sign, number 4, clear all lists. Now I'm going to go, I want to put in those 2 points, that 4, 6 and the negative 7, 3. So I'm going to go to stat and edit, and I'm going to put in 4, 6 and negative 7, 3. Negative 7 and 3. Cool. So that's the first thing that I'm going to do. So we got to be able to do this. Now I'm going to go second y equals. I'm going to turn my first stat plot on. I'm going to scroll down to here, and I'm going to do the first one, a scatter plot. I'm going to hit enter. I'm going to plot L1 with L2. I'm going to happen to do it in blue. You don't have to do it in anything, but we're going to hit graph next. Well, yeah, go ahead and hit graph. Okay, so you can see that my window and your window might not be the same. So I'm going to hit zoom 6, and now you can see, look at, those are the 2 points that we said were going to be on there. Sweet. And now I'm going to go ahead and put it in. Y equals negative 11/3 x minus 1. Make graph. So it might not look like that's a perpendicular bisector of this thing, but it only doesn't look like that because my screen is wider than it is tall. So I'm going to hit zoom 5 and it's going to square up my window. And now that looks a little bit more like a perpendicular bisector. But I'm going to teach you some more stuff. I'm going to show you how to find an equation of a line given these 2 points right here now too. And I'm going to show you with some additional things. So here we go. Ready? First off, you got to have the points in your stats. You got to have those 2 points there. Now what we're going to do is we're going to go stat and we're going to go calculate. And this button number 4 is pretty sweet. It finds an equation of a line given 2 or more points. 2 points, 3 points, 4 points, 5 points. Now if the 3, 4, or 5 points aren't all in a line, it finds the best one possible. It does something called a regression. So we're going to use number 4, linear regression. We are going to use L1 and L2. And right down here under store regression equation, we're going to do this. Watch. It's kind of cool. We're going to hit vars. You're going to go right arrow to y vars. You're going to choose number 1 function. And you're going to choose number 1 y1. We're going to store that equation in y1. So not only is it going to find the equation for us, but it's going to take that equation, it's going to stick it in our calculator. We will do this store regression equation a ton of times. Make sure you know how to do this. Now, if you have an older calculator, all you're going to have at the top is lin reg, and then you're going to put comma, or you're going to put y1 after that. So again, vars, y vars, function, choose number 1. Okay, so I'm going to go here to calculate, and it shows me, look, hey, there's my slope, 0.2727. There's my y-intercept, 4.9. But more importantly, watch this. It copied it right here into my y1. And now when I hit graph, you can see that, oh, that was bad. So I deleted my other one because I copied it over. Let's put it into y2. Negative 11 thirds x minus 1. Enter graph. And now you can see that's a perfect perpendicular bisector of those 2. Okay? So I'm hoping that that was really good for you. So this is what I would like you to try. We're going to do point C. Let's go 4, 8, and D, negative 6, comma, negative 2. And I want you to find the perpendicular bisector of segment CD. And so pause this right now, pause the video, and give that a shot. Like literally stop the video right now. Give that a shot. I'm going to do the answer in about 15 seconds, or at least do the work. I'm going to go a little bit faster this time. And then I want you to practice to do everything that you can to get it on your graphing calculator. So it looks like that. Okay, so here we go. Step number 1. This is what I want you to do. Plot it, right? 4, 8. 4, 8. Yay. Negative 6. Negative 2. Yay. There's my segment. There's about my midpoint. Perpendicular bisector should be someplace about like that. I'm not saying it's perfect, but it's going to be close to there. Okay, so I better again have a negative slope, and I better again have a, I'm hoping this one's a little bit better, positive y-intercept. Okay, so here we go. So step number 1, I'm going to find the slope of this one. So 8 minus negative 2 is 10. So slope, m is the slope, right? Slope of CD is equal to 10. 4 over negative 6. 4 minus negative 6 is 10. Wow, look at how easy this one's going to be. So the slope of that one's 1. So that means the slope of this one must be negative 1. So I'm going to have y equals negative x plus b. Now I needed to go through the midpoint. So the midpoint, 4 and negative 6 is negative 2. Half of negative 2 is negative 1. 8 and negative 2 is 6. Half of 6 is 3. Negative 1, 3 is the midpoint. So I just plug that in here. 3 equals negative 1 times negative 1 plus b. 3 equals negative 1 times negative 1 is 1 plus b. Subtract that. B equals 2. Y equals negative x plus 2. And look at that. That looks like a good y-intercept. That looks negative. That looks pretty good. And then check it all. Check it all right on here. So here we go. So I go to my stat. I go to edit. I'm going to put these in. So 4, 8. Enter, and then negative 6. Enter, and its partner was negative 2. Enter. I go to my y equals. I clear out these old ones. I'm going to go ahead and put this in y2, the one that I have, negative x plus 2, negative x plus 2, and I'm going to hit graph. That looks pretty close like a perpendicular bisector. Zoom 5 to make sure that it's still in that square window. I'm going to go ahead and put that equation in now too. Remember, we can do stat, calc, number 4, linear regression, store regression equation. I hit vars, y vars function, y1, calculate. Slope of 1, y-intercept of 4, hit graph. There's my original one, there's my perpendicular bisector. You guys are rock stars. I hope that you got that right. That will definitely be on the test. Make sure you can do that. Okay, this is Mr. Bells signing off. We'll talk to you guys later.